What if every compass on Earth suddenly pointed nowhere because our planet had more than one sunrise? What if ancient mass extinctions weren't random cosmic accidents but scheduled pulses from a hidden partner star? Elsewhere in the Milky Way, astronomers have discovered a fourth star orbiting a planetary system which was named 30 Ari that contains at least 4 suns, making the total number of known multi-starred planet systems to 2, but with thousands of 2- and 3-sunned extrasolar planets that have been found, where the effects of the other stars could also have a similar profound impact on orbiting planets. Surprisingly, a hidden star might even exist on the edge of our own solar system, possibly disturbing the Kuiper Belt and sending comets toward Earth. In this episode, you'll meet a teen who discovered a 2-sun planet just days into his NASA internship, citizen scientists who found a 4-star system from home, and so much more. But first, let's hear the spooky theory that had astronomers on edge for decades.
So someone suggested maybe it's in a binary star system where there's another star that plunges in through the solar system, coming through the Kuiper Belt, and then goes back out in this dance with the sun. So we wouldn't have seen it in our civilization, because this is, all right, but when it does that, it disrupts the Kuiper Belt gravitationally. And if you do that, you will send a rain of comets down, and you could render many life forms extinct on Earth, just the way we lost the dinosaurs from an asteroid. So, and they even gave a name for it. They called it Nemesis.
The quest began with a wobble. In 2011, NASA's Kepler telescope recorded a strange, staggered dimming from the binary system Kepler-16. The pattern refused to match any single star transit. Astrophysicist Lawrence Doyle finally cracked the code. A Saturn-sized planet, Kepler-16b, was orbiting both suns at once. Kepler's data revealed an incredible cosmic dance. 2 stars orbiting each other every 41 days, with a planet circling both of them every 229 days. For the first time, a real-life version of Tatooine from Star Wars had been found. Scientists used to think planets couldn't form in the unstable gravity of 2 stars, but this discovery proved otherwise. Kepler-16b is a cold world, around minus 100 degrees Celsius. But its double sunsets showed that planets can still form around binaries, as long as they stay far enough away. Fast forward to 2020. High school intern Wolf Kuiper was just a few days into his NASA internship when he noticed something unusual in the data from the TESS telescope. One strange dip in the light caught his eye. After 3 intense days of checking, he and the team confirmed a new planet, TOI 1338b, a Neptune-sized world orbiting 2 stars, 1,300 light-years away. Because the planet's orbit slowly shifts, it won't pass in front of its stars for much longer, making the timing of the discovery incredibly lucky. Sometimes, a sharp eye beats even the best computers. But the story didn't end there. Just last year, European astronomers using the HARPS and espresso instruments found another surprise in the same 2-star system, a second planet, this one as big as Jupiter, named Bebop 1c. Unlike the earlier discovery, this planet wasn't spotted by watching it pass in front of its stars. Instead, scientists detected tiny wobbles in the star's motion, caused by the planet's gravity. This proved something exciting. Systems with 2 suns can have not just one, but several planets orbiting them. Kepler-47 had hinted at this before, but BEBOP confirmed it. Multiple planets can safely circle twin stars without being flung into space. From these giants, let's zoom in on how they actually form. Binary chaos sounded wild enough, until citizen scientists on the Planet Hunters project flagged a light curve from Kepler-64 in 2012. The signal pointed to PH1b, a Neptune-sized planet orbiting a close binary every 138 days, while another binary pair orbits the whole ensemble 1,000 AU away. 4 stars, 1 planet, 0 stability, or so theory predicted. Yet PH1b keeps time like clockwork, proving that gravity can write orderly orbits even in a cosmic mosh pit. A few years later, astronomers made another big find, this time much closer to home. They discovered a massive planet, about 10 times the size of Jupiter, orbiting a star called 30 Ari b, part of another four-star system just 136 light-years away. This giant world orbits its main star every 335 days, while two other distant stars slowly move across its sky like drifting lanterns. The discovery challenged earlier ideas. If a huge gas world can survive in such a complex setup, could smaller rocky planets like Earth exist there too? In binary star systems, a gap forms in the middle of the planet-forming disk, but dust outside that gap can still clump into planets, like building a town just outside a busy city. Circumbinary planets often start farther out, where it's cooler, then migrate inward until gravity locks them into stable orbits, like finding the perfect parking spot. In systems like PH1, the outer stars are so distant that their pull is gentle, nudging the inner disk without disrupting it, almost like a faint moon in the sky. Life around multiple suns would bring strange day-night cycles, with long dusks, weeks of partial night and twilight during eclipses. But more stars mean more heat, potentially creating wider habitable zones. In systems like PH1, sunlight changes much like Earth's seasons, so stable climates could exist, just with a different rhythm. Atmospheres might glow in unusual colors, and plants could photosynthesize across different wavelengths. Nights wouldn't be as cold, showing that life can adapt in surprising ways. To find planets in multi-star systems, astronomers rely on a few clever tricks. Transit photometry looks for tiny dips in starlight when a planet crosses its stars. If there's no transit, radial velocity methods still pick up the subtle wobble in a star's motion caused by an orbiting world. Soon, telescopes like jwst and the Extremely Large Telescope will push the search further, capturing direct infrared images of these distant planets with coronagraphs and machine learning filters that separate faint planet light from the glare of multiple stars. Double sunsets and quadruple dawns. No sci-fi here, just raw pixels beamed back from space telescopes. Over the next few years, we'll study the air on these worlds, look for hidden moons, and maybe even live stream an aurora glowing under four suns. If that blew your mind, smash subscribe, tap the cosmic bell, and share this with the friend who never misses an eclipse. Strap in, because out in the universe, impossible is just the next discovery waiting to happen.